This week, we're looking at solving systems of equations using substitution and elimination. And today, we'll start off by using substitution. Okay, so last week, we looked at solving the system by graphing and looking at the point of intersection. This time, we don't have to graph, but we will come up with a point of intersection just by using the substitution method, and I'll show you what that is. So the first example we have up here is y equals 5x minus 7. And the other equation is negative 3x minus 2y equals negative 12. So what I'm going to do is substitute one of the equations into the other equation to solve it. So as you can see here, this one would be the best one to plug in or to substitute in because we already have it in slope-intercept form. So we're going to plug in the one that's in slope-intercept form. Now notice we have y equals 5x minus 7. So wherever I see a y, in my other equation, which is right here, I'm going to put 5x minus 7 in for it. And then we'll solve it. So let's see what that looks like. So negative 3x minus 2, and not y. This time we're going to take this and we're going to plug that in, substitute that in. So we're going to say 5x minus 7 instead of y equals negative 12. And we'll solve this. So I'll solve this by first distributing this negative 2 into the parentheses. Okay, and that would be negative 3x. This will now be minus 10x plus 14 equals negative 12. And I can solve this out. All right, so now I will have negative 3x minus 10x is just negative 13x plus 14 equals negative 12. Now I have move this 14 over, right? Minus 14 minus 14. Now I have negative 13x equals negative 26. Now I would divide by 2, and I'll put that up here. Negative 13x equals negative 26. So divide by negative 13 now. Because my whole purpose is getting x by itself. And that would be x equals 2. All right, so now I have my x. Now, what I could do is take this x and plug it back into that first equation that I used. So my equation was y equals 5x minus 7. Now, you could also plug it into this equation. Doesn't matter. I figured this one was easier because it's already in slope-intercept form. So take this now. This is part of my answer. That's x. Plug that in for x here. So we have y equals 5 times 2 minus 7. Then it would be y equals 10 minus 7, which is 3. Y equals 3. So my point of intersection should be 2, 3. All right. And I'm going to solve this one next. Let's split that up a little bit. Now, you could also plug 2, 3 into both equations just like we did last week and check it and make sure they work. All right. Next, you have this one. This one is the one that's slope-intercept form already. So I'm going to take this and put it in for y right here. So that would give me 5x minus 4 times negative 3x plus 5 equals negative 3. I'm going to go a little faster. You can slow this down, not slow it down, but pause it or rewind it if you have to. 5x, this will be distributed out, which would make plus 12x. And that would be minus 20 equals negative 3. Add the x's, you get 17x minus 20 equals negative 3 plus 20 plus 20. Remember, we're moving everything away from x. 17x equals 17. Divide by 17 on both sides. And x is 1. So I have x. I don't know why my pen is doing that. X is 1. And I'm going to plug that into my slope-intercept equation. X is 1, so I'm going to put 1 instead of x plus 5. Solve that, you would get negative 3 plus 5. Why is my pen doing this? I have no idea. Y equals positive 2.